Thank you. Good day. Greeting to the chairman and everyone. My name is Tan Sipei from University Malaysia Pahang. Today, I would like to present our study on investigation of mechanical characteristic on DMLS fabricated AlSi10Mg under tensile and fatigue loading. There are 4 sections to be presented today, which are introduction, methodology, results and discussion, last conclusion. The increase of demand for the lightweight and the geometrical complex component in aerospace, also in automotive sectors, has accelerated to adopt of a metal additive manufacturing, particularly for the aluminum alloys such as AlSi10Mg. Unlike the traditional manufacturer technique, the DMLS offers the different flexibility and reduce the material waste. It introduced a microstructural heterogeneity, residual stresses, and a process-induced defect. These features significantly influence the mechanical performance. To enhance the mechanical properties, the post-treatment are frequently applied. These treatments modify the silicon morphology and stabilize the grain structure, improving the hardness and ductility. However, from the structure integrity perspective, the strength improvement alone does not guarantee the reliability. Fatigue performance in the AlSi10Mg is primarily governed by the defect-induced crack initiation and the propagation mechanism. Therefore, the critical issue is not simply how strong the material is, but is how it behaves when cracks initiate under the cyclic loading. Although the extensive research has been conducted on the DMLS-Fabricated AlSi10Mg, most studies prioritize the static tensile property or the simple fatigue life measurements. Additionally, the load ratio, specimen geometries, and the testing frequency limit are direct compare between studies. Most importantly, there's limited attention has been given to the surface crack initiation and the early crack growth behavior. This is a critical oversight because in the cyclically low component, failure is often governed by the crack initiating from the surface defect or stress concentration. Without understanding the crack sensitivity behavior, improvement in the tensile strength or the hardness may provide a misleading indication of the structural performance. Without the baseline, the structure integrity assessment remains uncertain. Therefore, to ensure the reliable structure evaluation and the engineering application, it is essential to establish a baseline tensile and fatigue performance data under the control comparables condition. This gate motivates the present study by establishing the clear comparable mechanical data and evaluating the fatigue life performance under the both material conditions. So based on the problem encountered, the objective in this study are aimed to investigate the mechanical properties of a DMLS-fabricated AlSi10Mg. First is to compare the effect between the S-view and the heat-treated condition of a specimen. Second, evaluate the tensile strength and the fatigue life performance under controlled cyclic loading. Last will be establish a baseline mechanical data for structure evaluation that carry out by the configuration of an experimental work. In this study, the specimen is fabricated by a CAD input and printed by DMLS. After removed from the chamber, the part of a specimen will be further processed by the heat treatment on the stress relief, solution heat treatment, and artificial aging. Then all S-view and heat-treated specimen has been tested on the mechanical test by tensile, fatigue life, and fatigue crack propagation. In Figure 3, this shows the dimension of a tensile and fatigue test specimen according to ASTM. Figure 4 and 5 show the geometry for the compact tension CT specimen with the dimension as in the table 1. Figure 6 and 7 show the setup of a CT specimen by instrument machine. The evaluation of the critical stress intensity factor KC is carried out. The test is performed in the 2 stages. First is the pre-cracking. Second is a Paris region where it is conducted using the servo hydraulic fatigue test machine, while the crack opening displacement COD attached to the tips of the knife edge at the specimen. Based on the experimental tensile test result, heat treatment increased the UTS and the strain performance. Meanwhile, most of the literature results show the UTS are decreased but increased in the strain performance after heat treated. However, YC's studies show the reduce on both UTS and the strain after the T6 heat treatment. For the fatigue behavior, the fatigue life result is better compared to the previous study. One of the reasons is the author performed the solution heat treatment for T6 is in different way in terms of a duration period. In comparison, the SBU specimen in comparison to the SBU specimen, heat treated show the similar number of cycles in a manner of a stress range. Favored fatigue behavior in a low stress range with no overrun during the test, even performed at the maximum stress. At the stress more than 200 megapascal, the fatigue life limited to the low cycle regime. The T6 specimen show the longer fatigue life at the comparable stress level. The residual stress is reduced and the grain stabilization improved homogeneity also reduced scattered. Therefore, the T6 treatment significantly enhanced the fatigue resistance. As previously mentioned, Paris law is applied in predicting the fatigue crack growth. From the fatigue crack propagation result, the evaluation of the value C is on the material property. C is 1.85 times 10 to the power of -9, while the N is 3.69. In Figure 12, present the fractographic assessment of the CT specimen. During pre-cracking under the constant loading, the crack propagation is stable and linear, produce a relatively smooth fracture surface. However, once the crack reaches approximately half of a specimen width, a rapid unstable growth occurs. The fracture surface becomes rougher, and the small shear lips are observed along the free surface, indicating the predominantly the brittle behavior with a limited plastic deformation. Monitoring the shear lips formation is essentially to ensure the experimental validity. Therefore, using the measure critical crack length prior to instability, the critical stress intensity factor was calculated due to the KIC value of the 15.54 megapascal square meter. In conclusion, the mechanical property of this alloy after T6 heat treatment, the tensile and the ductility are improved. At the same time, the fatigue resistance also improved compared to the SBU condition under equivalent loading level. And lastly, the combined improvement in the strength, ductility, and cyclic stability indicate the post-T6 processing plays a critical role in the optimization, the structural performance of a DMLS-Fabricated aluminum AlSi10Mg. Lastly, thank you for your attention.